Hi, Assalamualaikum, and I'm from Group 8, and I want to talk about our project, which is known as Hydraulic Robotic Arm, and it is powered by hydraulic system based on Pascal principles. And as you guys know, hydraulic pumps are used widely everywhere, for example like factories or even construction sites and car workshops, right? And they rely solely on Pascal principles, which where pressure applied to a fluid in a closed system is transmitted equally. Thus, this helps to allow a small force on a small piston to create a larger force on a larger piston. But here's the thing, while this concept being very powerful and help with heavy machinery, why do we use this exact concept to help people with disabilities, right? And that is what our main objective in our project, which to create a hydraulic hand system that amplifies strength using Pascal principle. And it's simple, cost-effective, and could make a real difference in someone's life. And the goals are very clear here, which to give people with disabilities a better chance at living independently and to develop a cheaper alternative to robotic arm, and to show how something that is we learn in physics class can be used to solve a real world problems. And I think that is. And if you guys wondering how we do this kind of project, let Syafiq explain it to you guys.
The objective of this project are simple yet powerful. First of all, we aim to give disabled people a chance to live a normal life. Other than that, we also aim for our model to be produced at a lower cost than developing a robotic arm. Furthermore, we want to test the functions and the capabilities of our proposed model. And finally, we want to be able to show the concept of Pascal principle in our daily life. This could serve to teach into deeper understandings of physics, engineering, and fluid dynamics.
For methodology, for equipment and material used in our project is hot glue gun, cutter, box, wooden stick, ice cream stick, wire, strings, tube, oil water, and last but not least, cable tie. Okay, for the procedure we made the project is first we measure and cut the box with specific measurement. Then we make the hole at the tail of the string. Use the hot steel. Next, for the body part, we use two bolts and combine with the stick. And between the two bolts, we put the strings. So we move to the upper parts, and we divide to two, arms and hand. So for the arm part, same as the body part, we use two bolts and stick with the wooden stick, and use hot glue gun to make sure the stick is not move out from the box. And for hand part, we use the crab shaped box and combine with the base and stick them with the wooden stick. So use hot glue gun to make sure the stick is not moved. And lastly, we use the wire steel hook at the crab shaped box with the string at the arm part. So when the string move, the hand will move to grab something. So after that, we combine the body and the upper parts with the stick, and also you make the screw-like box to make sure the body and the upper parts not move. Last but not least, for the base, we use a square box that we cut like 20 cm, and we cut two quantity. So we combine both to make sure the thickness of the base is higher. So we combine the base and the body part together, and tada! Our project is finished. That's that.
After we finished building the model, we did several tests to see how well it works. We test how strong and stable the model is by asking it to pick up different everyday items. These objects had different size and weights, such as a pen, a glass, a mobile phone, and a plastic bottle and a food container. The first few tests went well. The model was able to pick up the light item like a pen, a plastic bottle, and a food container. It held the pen firmly and moved it without shaking. The plastic bottle was also lifted without any problem. The food container, although slightly bigger, was handled smoothly. The arm stayed steady and the grip was strong enough to keep the items from falling. Next, we test with heavier or more delicate items like a mobile phone and a glass. This time, the model had some trouble when trying to lift the phone. The arm became a bit shaky. It still held the phones but not as securely. When we moved onto the glass, the model leaned forward while lifting. The grip was not strong enough and the glass almost slipped. This problem was mainly caused by the light base of the model because the base is not heavy or stable enough. The model tends to lift forward when lifting heavy items. This makes it harder for the arm to stay balanced and steady during the movement. These results show that model works best with small and light items. It can also lift medium-sized objects like a food container without any problem. However, it struggles with heavier or fragile items due to the weak grip and unstable base.
In conclusion, this project applies Pascal's principles to a hydraulic hand model, aiming to replicate the structure and function of a human hand. The main goal is to support individuals with disabilities by providing a low-cost, functional alternative to commercial prosthetic hands. Compared to existing market options, this model is significantly more affordable, making it more accessible to the community. Currently, the hydraulic hand is capable of performing simple tasks such as holding lightweight objects. However, this also highlights the need for further improvements in both materials and design to enhance its performance and expand its potential applications in the future.